This is the second example for the theoretical and experimental probability lesson. So please make sure you're on this page in your notes. You can pause the video each time and try to figure out if you're really understanding this. Pause it before I give answers and then go see what happened. If you're racing through these, you're not going to understand what you're doing in homework, and these are the examples to help you work through and try to get to your own understanding. So the last example, they gave you what happened when they rolled one of a pair of dice. So they rolled a die. And on a die, there are always the numbers 1 through 6. So those are the possible outcomes, is that I might roll a 1, a 2, 3, 4, 5, or 6. They ran an experiment and they recorded how frequently they got each of those outcomes. So when you add up all the total number of ways that they had different numbers come up, there must have been, and you can check my math here, 100 trials run of this experiment, because all the frequencies add up to 100. Now, before we go answering some of those questions, if we had done 100 trials, we might want to think about what we expected. How often do you expect a 1 to come up on a die? And expected, remember, is theoretical. In theory, every time we roll a die, we should have a 1 chance out of 6 equal chances of getting a 1. We should also have a 1 in 6 chance of getting all the other different numbers on the die. So now let's go see what they would like to know. So in each time you answer these, you have to check theoretical versus experimental to decide what type of probability you're calculating. So the theoretical probability of rolling a 4, well, what that means is the expected probability. And we calculated that the theoretical probability of rolling a 4 is that there's 1 4 on a die out of 6 equally likely things to happen. So we would expect, and if we did this as a percent, so you can think about this, that's about 16.7% of the time we expect to get a 4. Now then they actually went and ran an experiment, and they said, well, that's not what actually happened. How frequently did a 4 come up when we ran our experiment? So now we have to go to the data that came up. Rolling a 4, they rolled a 4 10 times. Well, 10 times out of the 100 times that they rolled the die in their experiment, the 100 trials, and that's only about 10% of the time. So you're calculating 2 different types of probabilities each time based on whether or not they ask you for theoretical, what's expected, or whether they ask you for experimental, which is the result of some outcomes and frequencies that you actually did as an experiment or that you were given the data for. The experimental probability of rolling an even number. So in the experiment, an even number would have come up 20 times as a 2. That would have been considered a possible outcome that would be successful. 10 more times because they got a 4. And 14 more times that they got a 6. So those are all the ways they got even numbers. But this is experimental, so it's out of the 100 times that they tried that. So that's 44 out of 100. So the experimental probability came up 11/25, or 44% of the time. The theoretical probability of rolling an even number is different. We expected that of the 6 rolls, to get an even number, we would have been happy getting a 2, a 4, or a 6. So there were 3 ways I could have gotten an even number. So 3 times out of 6, I'd expect to roll an even, or half the time, or 50% of the time. And again, it didn't match, as most experiments don't, unless you run such a large number of trials that they'll get very close. All right, the experimental probability of rolling less than a 3. So experimental less than a 3 would mean that a result of either a 2 or a 1 would have been successful. So 16 plus 20 of my trials were successful for this event of rolling less than a 3. Out of the 100 trials in the experiment, so 36 100ths, we're looking at 9/25. If we reduce, and please make sure tonight on homework that you reduce, or about 36% of the time. In theory, rolling a number less than 3 happens for 2 different outcomes. If I roll a 1 or I roll a 2. So there are 2 different outcomes of the 6 that I'm okay with. So that would be 2/6 of the time, which is 1/3, or about 33%. Again, those are different. So when you do your homework, you need to come back to these to look to see whether you use the data from the experiment to get your experimental probability or the expected outcomes for your equally likely events to get your theoretical.